Assalamualaikum everyone. Welcome to the first lecture for the computer aided drawing class. So today we are going to cover the introduction to engineering drawing and also GDNT. So for the first part of this lecture, we are going to cover the introduction to engineering drawing and also lines. And the second part will be in the geometric dimensioning and also tolerance. As an introduction to the engineering drawing, we would like to see the definition on the engineering drawing. Engineering drawing is basically the technical drawing where it is used to define the requirement for the engineered item. So this one must follow the standard so that it will be convenience to all the people that read the drawing. So they have certain layout, certain appearance, size, and etc. So this we're going to look into in detail later. So the purpose will be to accurately and unambiguously capture all the geometric feature of the product or component. And the end goal for the engineering drawing will be that it will be able to convey all the required information so that it will allow the manufacturer to produce the component the way that we want it. Under the engineering drawing, there are two languages, which is graphic language and word language. So since it is a drawing, so it will describe the shape, use line to represent surfaces, edges, contour, and the characteristic of the objects, and then this is known as the drafting of the drawing. For word language, it will put the location and specification of the object, and it will also describe the size, shape, and also the features of the object concisely. So technical drawing serve one of the three purposes. So either it is used for visualization, or it can also use as communication, and another one is for documentation. Okay, so visualize so that other people can visual what are the things in our mind, what are the things that we want to convey to others. Another one, communication, so that one engineer to another engineer, they will be able to communicate through the drawing. They know, oh okay, um, these people want to produce this thing, this thing, this thing. So in order to produce that thing, another engineer will have to read the drawing so that it will become a medium of the communication. And the third one will be documentation, so that it can be documented and it can be given to other people so that people can use it, and then they can also maybe in the future they have to redo or to make the object again. So then the documentation is already ready. Okay, you don't have to do the drawing again. A drawing can be created in three ways. One is freehand sketch, second is using typical drawing instrument, and the third one is using the computer, which is using the software. Now let us look some example of the drawing that created through hand sketch. For the first one, it is a design for water clock of the peacock that drawn by Al-Jazari. Okay, so this one showing the hand sketch done 100 years before, but then it can still be preserved, and other people till now can look into the drawing. The second one is the surgery tools by Al-Zahrawi. So this one also created by using hand sketches. During this time, there are still no technical drawing in particular. Okay, there is no standard, but then everyone can read and also can understand the hand sketches. And this is another drawing by Al-Jazari, which is the elephant clock. And from that hand sketches, actually they are able to recreate that elephant clock, and it is placed in the Al Batuta Mall in Dubai. Okay. Another example of hand sketches, if you are familiar with this picture, it is sketches by Leonardo da Vinci. Okay. The next method to create the drawing is by using the instrument. So this is what we call as manual drawing. So in this drawing, the drawing is drawn using instrument, where all the straight lines, circle and curve is created concisely and accurately using the instrument compared to the hand sketches previously. So this one also usually is made to scale, so that it can scale to the actual product that going to be created, or the actual product that's visible. Here are some instruments for manual drawing. So usually people will use drawing board, T-square, drawing sheets, drafting tape, or masking tape. Okay, pencil, eraser, sharpener, T-square, set squares, triangle, scales, compass, and divider. Okay, so these are the example of the and the picture of the instruments. However, nowadays people are shifting from the manual technical drawing, into a more modern way, which is by using the computer. Usually it will made by commercial software, for example, CATIA, AutoCAD, SolidWorks, Libre, and etc. There are a lot of software out there, and these are the drawing that we are able to manage to draw using the computer. So this is the 2D drawing, and the right one is what we call the 3D drawing, or we call it as solid modeling. So engineering drawing have certain standard. So a standard is used as a rule so that it can govern how technical drawing are represented. So why do we need this engineering drawing standard? It is easy. It is because we want to say to convey the same meaning to everyone. So when we use one standard, one language, so everyone will understand. So that's the meaning under the drawing standard. So for engineering drawing standard code, there are several standard actually. For in this world, they have ANSI, which is American National Standard Institute, JIS, Japanese Industrial Standard, BS, British Standard, AD is Australian Standard, and DIN is Dutch Institute for Normal from Germany. Okay, so this is created way before, and in order to make it easy for everyone, so that everyone in this world can understand, there is one standard that what we call as ISO standard, which is International Standard Organization, so that we can make it into one language. So most people are using ISO right now. Maybe there are also people still using ANSI or JIS, but then uh, if we want to understand that one, we have to learn about that standard. Okay, so mostly in the world, people are using ISO so that everyone can understand the language. So as I've mentioned previously, Indian drawing is drawn by scales. So this one is to represent the size of the actual part to the drawing. So for example, if you can see in this, the first picture, it is a full scale, which is the size of the drawing, and the actual product to the drawing is the same, meaning that it is convey the same dimension. Okay, so that will be scale 1 double dot 1. So this is a full size. Now we go for the second one. When you see that the scale is 1 double dot 2, so what happened is the drawing is being reduced to half. Okay, the drawing is become smaller, and then this one is for the scale 3. Okay, and the second one is twice scale, which is the scale of the drawing is double from the actual product. So it become scale 2 double dot 1. Okay. So if you go to this drawing into the scale, so you can say that the first one is represent the drawing, and the second one is representing the real measurement of the product. Another part that you have to know in the engine drawing will be the lines, the basic line that have in the uh, engine drawing. There are continuous stick line and continuous thin line. Then they have dash and also change line. So what's the meaning of this line? So for the continuous stick line, it is called visible line, where it represents the features that we can see in the current view. And then the second one is continuous thin. So this is usually used for dimensioning line, extension line, and a leader line. So this one we're going to see later. And then we also have hidden line. So this one represent the features that we cannot see in the current view, but it is there. Okay, and this is usually using the dash line with this, which is thin. And the last one is change with which is used for the center line. Okay, so this one represent the symmetry, path of motion, center of circle, axis of and axis of asymmetrical parts. So here are the example of the lines, what we call as a visible line. What is visible line? Is when you want to represent the parts that you want to show. Okay, so this is the outline of the product. So then it is a visible line which is thick. Okay, now then we have the dimension line. So if you can see, the thickness of the line here is thinner compared to the visible line, right? So this is the continuous thin line. We use it for the dimension line. We use for the extension line, so to extend the and show the dimension. And we also use it as the leader line. Okay, so that's why it is thinner compared to the visible line, so that it will not create confusion to the part that we want to show. And the last one is the dash. So if you have a circle, so you will have to use the change line like this one. Okay, like this. So this is usually used for the center line. So it is a change and also it is thin. Okay. So here are some example of the type of line that used in the drawing. So for example, the first one is the visible line. Okay, so if you can see, the line is thick and also to show the actual features of the product that you want to draw. So this one is second one is the hidden line. If you can see here, this is a circle. If we look it from the top, you can see the circle here, right? So if we want to see it from the front, you will not be able to see the circle inside the product here, right? So we have to represent it by using the hidden line, which is the dot line. Okay, so with the measurement is usually like this one, but in the drawing we are not really measuring one by one like this one. You just estimate the distance between the lines, so that as long as it is uniform, then it's okay. Okay, so the third one is section line. So there will be a sectional view. So if you, for example, you cut this part, and then we want to show the inside here. So what we have to do on the parts that have not hollow, it will become the hatching like this one, what we call as section line. So this one is supposed to be continuous thin line with the 45-degree slanted. This one we're going to look later in detail. And then we also have center line like previously. Okay, so it is change type. And then we also have the symmetry. So if it is symmetry, there will be something that like this one. Okay, so this, if you see this line, meaning it is a symmetrical part. And then we also have the dimension line, extension line, and leader, like the one that we see in this one. Apart from that, there are also other lines that you will see inside here. For example, the cutting plane line, and then we also have the viewing plane lines, short break lines, long break line, phantom lines, stitches line, and also chains line. So this is some example on how the thickness and the type of the lines is being used inside the engineering drawing. So that's the end of part 1 of lecture 1. See you in part 2.